Hello, I am Fazla Lincoln. My student ID is 221666011. My video topic is about how to clean data with OpenRefine for the course code CSA 713. So let us start about what is OpenRefine and how can we clean data with OpenRefine. So let's head to the introduction. So what is OpenRefine? OpenRefine is a tool or software for data cleaning. It can differentiate data cleaning from data organization, experiment with OpenRefine's user interface, and many more. So there are some motivations for OpenRefine lessons. Data is often very messy. This tool saves a lot of time cleaning the data sets. So first we need to install OpenRefine, which I have already done, and then we need to download data file, which I also have done. Then so what is a dataset? Dataset can be in different formats like CSV, TSV, and many more, and resolve inconsistency in dataset, match local data up to the dataset, and many things. So let us start working with OpenRefine. So head back to the second step. So how can we bring our data into OpenRefine? How can we sort and summarize our data? How can we find and correct errors in our raw data? So in this video we'll learn about how to create a new OpenRefine project from CSV file, recall with facets and how they are used to sort and summarize data. Recall with clustering is how it is applied to group of edit typos. We can also manipulate data using previous steps like Control V2. So let us start with creating a project. So here is my folder, and I have already downloaded OpenRefine. You can see it. So let us start with the exe. So it will pop up with a browser extension like 127.0.0.0, and the port ID is 3333. So here is my dataset already downloaded. So we'll head to choose file option and choose the dataset and next. So here we can see the project name is the dataset name, but for now I will rename it to my student ID. And then we can also view data in different formats like CSV, TSV, or trim, leading and trailing space from string, and then we can create project here. So it's already done. So here we can see our different columns and different rows, and here is my project name, and we can see that 35,549 rows in our data sets. So there are many more records. So here are some scientific name, locality, JSON, decimal latitude, country, state, and many more fields, and many are empty and many have data in it. So we will refine, or we will define our dataset with OpenRefine. So we will start with filtering and sorting. How we can filter or sort with OpenRefine. So let us start with facing. So facing is exploring data by applying multiple filters. Facets are one of the most useful features for OpenRefine and can help both get an overview of data in a project as well as helping you bring more consistency in dataset. We can see big picture of our data. We can filter down just to see the subset of our data. So facet group are like values that appear in a column and allows you to filter the data by those values. So we'll scroll over to scientific name and click on facet, and we can see that the text facet, memory facet, timeline facet, scatter plot facet, and many more. Custom facet also there. So we'll click on text facet, and we can see that there are many more field name like Amphisia bilinita, that has count 1, and Amphisia bilinita and also count 1. We can see that there are two records with same name, but I mean any character or space is different, but we can understand that they are same. So we'll refine this later. So we can sort by name or count here. Then we will head to the scientific name text facet. So we'll sort by name and count, which I have already done, and then we can see the edit option. So we can yes, as edit, and we can rename this record data. So can we fix the misspelling? As we have seen, there are multiple copies of same data, but with a mistyped text. Yes, we can refactor the misspellings here. So we can sort by numeric scatter facet, but as it is a text facet, we cannot we won't see any numeric facets here. Scatter plot facet will also show nothing here. And we can use to timeline facets. Yes, there is no timeline here. So timeline facets are applied to date, and numeric facets is applied to only the numeric values, not in text values. So here like stake, we can numeric facets, and there is a numeric value, but because this stake is not in numeric format but in text format. So here we then there is some exercise using faces. Find how many years and represent in the sensors which year have the most and least observations. So for so head to the year column and click on okay. First we need to remove all the previous faces. Okay, we click on faces column, and here we can see that there are text faces. So we can sort by count here. Okay. So we can head to faces and sort by count here, and we see that 1997 has the most most repetitive records, and the least one is 1977 with 503 count. Okay. Okay, the column is formatted now as text, but we can also refactor it to number. We can refactor any columns to number, like here. Yes, here is edit cells. Go to edit cells, then common transform, and then two numbers. Okay, so here's the loading, and then boom, it is already numbers. So we can now apply numeric faces, and we can see that there's a graphing plot here. And then we can also head to timeline process, but there is no timeline because it is not a date. Scatter plot will not. Okay. Now we can head to the cluster. Well, first we need to refactor as it is was. Okay, let's cross it. Okay, done. Now we can now we will learn about clustering. Clustering is finding groups of different values that might be alternative representation of the same thing. For example, the two string New York and New York are very likely to refer to the same concept, just have capitalization differences. Likewise, Godel and Godel probably is the same. So in the scientific name text spaces we created in the steps. OpenRefine has several clustering algorithms built in. Experiment with them. We will experiment with them now. So we will head to the scientific name and then cluster, edit cell, and cluster and edit. Okay, let's go to our scientific name column. Okay, let's facet and text facet. Okay, we can see the text facet here, and then cluster. Okay, we can see that. Okay, edit cell, cluster and edit method. Okay, there is some keying functions. Okay, select the key collision or meta from 3. There are several algorithms to cluster. So we can see the key collision here, and fingerprint, keying function fingerprint. We can see that meta from 3. Okay, as we already guessed that there's the same data set with different name, but that will be the same, like amphisia vignetta, but we have misspellings, so we can refactor this to the same data. So we'll now merge and keying function. Okay, there are several keying function result will give us different results. So you can merge, click on select all. Okay, merge, select and recluster. Okay, close. Now amphisia vignetta is only 2 counts, and you can sort by count, refresh it. we don't see our repetitive data for misspellings. But let's practice or let's experiment with some different keying functions. Text spacers. Okay, text spacers. Now change the cluster. Click on cluster and fingerprint. Okay, fingerprint is also showing two objects with that should be similar object. Then fingerprint. Okay, no data. Data from 3, no. Okay, so you can see that there are no more data sets with okay, there is one. We can combine these two. Billianeta, Cilianeta, I guess this is a misspelling too. Okay, and now click on this. Not okay. Are these two similar? No, I guess not. But yes, these two I guess not similar. Okay. The next more times of this. Okay, next we will learn about splitting our data sets. Like we can split by commas or split by space or split by any text. So let's head to the scientific name column and we will edit column, split into several columns by comma or space, I guess. Yes, by comma or space. Edit column, split into several columns. Let's head to our scientific name column, then click on edit column. Yes, split into several columns by separator. By default is comma, but we can put any text here or many or empty space. Okay, comma, but there is no cells splitted because there is no comma in scientific name. But we can see the scientific name column has been renamed. We will fix this, no problem. Let's set to again our scientific name and click on okay. Let's see what we have missed. Okay, there is some steps like undo redo. We can undo to our previous step. Yes, now we have scientific name is not renamed now. Apply, cancel. So we can scientific name phases. Okay, edit column, split into several columns by space this time. We will split our columns by space this time. Okay, now you can see that there are two columns replaced. Scientific name is replaced by two columns, scientific name 1, scientific name 2, and the text is splitted by space. So we don't want to rename our, or we don't want to replace our previous column. Okay, for that we can see that there is an option. There should be an option. Okay, remove this column. We should uncheck remove this column. Okay. Yes, after splitting, remove this column. Okay, we need to undo our previous change. Yes, now scientific name, click on scientific name, edit column, split into several columns. Now remove this column, we can untick this and by space, my separator is a space. Now we can see that scientific name is still there, but there are two new columns, the scientific name 1, scientific name 2. It represents the space, the splitted text of scientific name. Okay, so there is an exercise. I try to change the name of second new column to species. How can we correct the problem encounter? Okay, scientific name 2 column, we can rename any column like this. Click on scientific name, click on edit column, click on rename this column. Okay, but we won't rename this column, but we will rename scientific name 1 column. You can click on scientific name column, click on edit column, then clicking on rename this column, we can just paste the columns, put the name here. Column is okay, there is an already existing column, so we can rename to a separate text like a species name or anything else. Okay, scientific name 2, edit column, rename this column, and okay, species name. Okay, then we can undo redo. It's a common. Okay, yeah, we can mistakenly click on any operation which we not intend to. Yes, we can undo redo any steps we have done. So let's head to our here we can see that facet filter. There is a tab undo redo. Okay, we click on it and we can head back to our previous step. Okay, next we will head to the third step of filtering, sorting with OpenRefine. Okay, so we can how can we learn about employee text filter, include exclude filter, sort tables by column, sort tables by multiple column. So we will learn this part of this video. So let's head to the filtering section. Scientific name, text filter, a scientific name facet will appear on the left margin. Yes, it will appear. Then we can type anything to filter our text. Okay. Okay. Let's head to our scientific name and click on text filter. Text filter is there. Okay. Click on text filter. Why doesn't it show anything? Why doesn't it show anything? Let us. Okay, apply. Facet filter. Okay, here is the search field. Okay, we can filter by BAI. Okay, let's see Bimos Failory. Bimos Failory. So these are the record of Bimos Failory. We can show 50 records or 100 records, 100 rows. Okay, we have clicked on 50 rows, and there is another like AI starts with small letter. So we can there is some exercise. What scientific name selected by this procedure. Okay, facet text for scientific name, column auto filtering. This will show two names, natural filter. Okay, so currently the filter is not in case sensitive, but we can make this case sensitive. Click on scientific name, facet, text facet. Okay, then the type BAI and press return. Okay, so go to case insensitive. Okay, now there is only the two records are shown for by with starts with small letter, and regular expression is every data. I mean, it's not in case sensitive. So we have seen that how can we filter our data with a part of text. Now if we click on BAI, I mean capital starts with capital B, then we will see that only okay, case sensitive is not there, case sensitive is not there. Yes, there. Yes, case sensitive is there now. So we can see that only Bimos Failory is shown because it's start with capital B. So excluding entries, we can include or exclude entries from one of the two species. So in addition to solution included above, another way is to narrow or filter, include or exclude. Okay, facing and filtering look very similar, a good distinction. So faces by choice count. Okay, we can see that. Now we'll head to our sort section. So we'll see how sort is done in OpenRefine. We can sort data in column by using drop down menu available in the column text, number, date, boolean, etc. So you can sort by text, sort by number, sort by date, or sort by boolean value. Okay, so let's start with our sorting with OpenRefine. Okay, go to OpenRefine, then clear our facets, and then text filter, scientific name, go to sort. Okay, here we can see that we can sort by text. It's not in case sensitive, but we can sort by sort, reverse, remove sort. So we have already removed sort, but we can create another sort like sort by numbers, but it will show nothing. But if we say sort by Z to A, then the whole records are upside down, I mean starts with from the last records. Then sort by if we reverse, then it is like previous. Then sort by numbers. Okay, sort by numbers, valid, value, zeros, blanks, drag and drop to reorder. Okay, we can drag and drop, I mean which values to show up, like valid values, then errors, then blanks. So you can sort by boolean, true then false, but it will show nothing because these are text, not boolean values. So we remove sort, and then okay, sort by there is an exercise, sort by month. How can we ensure that months are in order? Okay, we can easily create our months record in order, like click on mo month. Okay, sort by numbers won't affect here because yes, because these are in numbers. Okay, it's affected. Okay. Then we can reverse it, like it starts with 12, you can sort, remove sort. Okay, it's like as it was initially. Then there is exercise, sort by data, by plot, and here our observation recorded the plot 1 in this filtered dataset. So in the plot column, click sort numbers and smallest first. Okay, so yeah, okay, plot, yes, by plot. So click on the plot record, then click on sort, then click on numbers, then click on OK. Then okay, then head to our sort again. Can we do something else with sorting? No. And sorting by multiple column. Okay, if we want to sort by multiple column, how can we do that? So sort by this when sorting, there is an option, this is called sort by this column alone. If we tick this box, then the column then whole record is sorted by only this column. So if we go to plot, sort, then sort. Okay, where is the sort by this column alone? Okay, how can we find the sort by this column alone option? So sort numbers, then numbers. Okay, for month, sort by numbers, for month. Okay, go to month, year. Okay, year, sort. Okay, here is the option, sort by this column alone. Okay, then only the data is sorted by only this column. How do we sort by month? We have already done that. Let's do it again. Sort, head to month, head to year, then sort, remove sort. Okay, we will remove sort. There is no sort. So we'll now learn about examining numbers in OpenRefine. So how can we examine numbers in OpenRefine? So we can transform a text column into a number column, identify and modify non-numeric values in a column using facets. We can use scatter plot facet to examine relationship among columns. So numbers, when a table is imported into OpenRefine, all columns are treated as having text values initially. We saw that earlier, didn't we? Okay. So even there is numeric, but the numeric is represented as text, not in numbers. So we can always transform any column into a different data type. So for this we need to head to edit cells, then common transform. So there is a okay, we need to remove any text filter if we have applied previously. Okay, so we can undo our previous steps. To transform cells into record ID column to numbers, click on the down arrow column, edit cells. Okay. So go to record ID, then go to edit column and go to edit cells, then common transform. Okay, unique uppercase to uppercase to lowercase to number to date. Okay, to number, so which we have already done before. So we can edit cells again, common transform to text. Now it is in text format. Then okay, from to text to numbers. Okay, here it is in numbers now. Then we can transform cells into record ID. Okay, transform, there is exercise, transform 3 more columns including period from text to number. Okay, not all columns can be transformed to number, because only the numeric values can be transformed to numbers. So we can head to the portal rodents or dataset, then click on scientific name, click on edit cells. So click on common transform to number. It will show that there is no text transform is 0 cells. You can undo it. Then numeric facets, sometimes there are non-numeric values in blanks or column, in which way may represent errors in data when we want to find the numeric facets. For any column, for a column, transform to number, edit 1 or 2 cells, replacing the numbers with text such as ABC, blank or OK. Notice that there are several checkboxes in the facet: numeric, non-numeric, blank, error. Below these are counts of the numeric of cells is category. You should see checks for non-numeric, blank if changed some values. Okay, head to our dataset, then click on record ID. So we can see that numeric facets and there is some record ID. We can filter down to how many data rows we want to see. Then click on scientific name, facets, numeric facets. It results nothing because these are non-numeric values. So again we can undo our previous steps to mass edit these cells before text transform, or we can head to our previous initial stage where we have created our project. Then there is a scatter plot facet. Now that we have multiple columns representing numbers, we can see how they relate to one another. Using the scatter plot facet, we can see that easily. So we need to click on facet, then scatter numeric facet. Okay, it will show nothing. Then edit cells, we can transform to numbers, then we can create numeric facets here. Okay, then we can examine pair of columns in detail. So record ID and then period, edit cells to numbers, then period, edit cells to numbers we have already done. Okay, in numeric facets. So we can see that there are defined plots, record ID versus period. So this exercise is done. Examine pair of columns in detail. So we can reset this or refresh this. So there are 2 plots, scatter plot. So record ID versus period. We can filter down. We can like apply text filter here. So which we have already shown in previous steps. Then can refresh this. Tips from OpenRefine, how we can export scripts. So what is scripts? Like we can generate our OpenRefine into JSON code. So scripts are the steps, like what we have done in our dataset or with our dataset. So like undo, redo these steps. So we can extract these steps in JSON data or in text format. So for now we'll export our steps. So for now here we have three steps actually, 0, 1, 2. So we can select all and then export. So this export is history.json format. So we can we have removed our previous steps, so it will show more scripts. It would show many more scripts if we didn't remove the previous steps we have applied to our datasets. So exporting and saving data from OpenRefine. So how we can export our data after cleaning our dataset? So save our OpenRefine project or export clean data. So we can export export button in OpenRefine project, and we will pop up with a zip file or tar.gz file to download our clean data. So we will see that in this video part. Okay, so let's head to our facet filter, and then here is export and OpenRefine project archive to file. Okay, so here is our whole project including our dataset, refined dataset here. So I have already, okay, as I have recorded my browser screen, so I cannot show you my desktop view here. And then other resources. Okay, what we can do if you want to learn about what more we can do with OpenRefine, we can find it in this blog. So thank you. That was all about that was the intro to OpenRefine, how we can clean data with OpenRefine. So thank you all.